Hello, welcome to all of you. I, Dr. Pradeep Srivastava, welcome to all of you in my class, Water Resources Engineering. Today's topic is the canal irrigation. My dear boy, actually, canal. First, you think, what is the canal? Canal is a system, is a channel which are carrying water from reservoir to farmer's field. That is called canal. So, what is objective? First, we will discuss. A canal is an artificial channel that is constructed to carry water to the field to perform irrigation. The water is taken either from the river, tank, or reservoir. The canal can be constructed either by means of the concrete, stone brick, or any sort of the flexible membrane which solve the durability issue like seepage and erosion. The distribution system in a canal irrigation system, canal alignment, curve, and a certain feature of the canal irrigation are bring explained in the article. So canal or waterway, channel or artificial waterways for water conveyance or it to serve water transport vehicle. They may also help with the irrigation. It can be thought of as an artificial version of a river. Canal carry free surface flow under atmospheric pressure. In most cases, the engineered works will have a series of dams and rocks that create reservoir of low speed current flow. These reservoirs are referred to as a slack water is levels, often just a cold levels. A canal is also known as the navigation. When it parallels the river and shares part of its water and drainage basin and beverage at resources by the building, dam and locks to increase and lengthen its stretch of the slack water level while staying in the contrast. A canal cut across the drainage, divide a top, the edge generally requiring an external water source above the highest elevation. So many canals have been built at the elevation, touring, overing valley, and other waterways crossing for below channels. The source of water at a higher level can deliver water to destination such as the city where water is needed. The Roman Empire aqueduct were such water supply of the canal. So, what is the again? We will read what is the canal. So I think have you seen canal? Just I am drawing it. My dear boy, this is the bank, this is the top, just a roughly idea. This is the channel. This is canal, this is the channel. It means we have made a channel which to carry the water. How water will go? How water will go? Yes, dear boy, water will go by gravity. Suppose, think that a dam is a river. This is a river. Suppose you have provided a barrier like in the shape of barrage, in the shape of dam, in the shape of beer. So if water flow is here, here, but you have stopped the water, you have put up a barrier, you have tried to stop the running of the water. So dear boy, what will we do? Water will be stored and it will be rise and it will be rise like this and it will be spread to this area. Entire this area will be full and water will be rise. Now think that this water have stored up to 5 meters, 6 meters, 7 meters. So if former land are here, you can make a canal come to here for irrigate like this. This is the system of canal. The water will come by gravity. Water can be go by lift also, but it is the first priority. The water will be come by gravity. Okay. Now a canal is an artificial channel, generally trapezoidal, in shape constructed on the ground to carry water to the field either from the river or from a reservoir. Clear? This is the system of canal. And now, what is the classification of canal? Classification based on the nature of source of supply. Suppose first nature is the permanent canal. Second is the inundation canal. And now classification based on the financial output. So productive canal, protective canal. Classification based on the function of the canal. First, irrigation canal. Second, carrier canal. Third, feeder canal. A fourth, navigation canal. A fifth, power canal. Okay. So classification based on boundary. Surface of canal, alluvial canal, non-alluvial canal, and ring boundary canal, ridge boundary canal. Now, classification based on discharge and its relative importance in a given network or canal. So first, main canal. Second, branch canal. Third, major distributary. Fourth, minor distributary. And fifth is a waterproof. So I will explain in detail, but I want to show you what is the definition, practical definition of these. Suppose, my dear boys, this is the river. You have stopped here and given a way, and this is reservoir. So this is the planning. This is the command area. So canal from here, it will come here and it will come here. So this is the main canal. And now branch canal. So this is the branch canal. Now, what is the major distributary? So why this is the major distributary? Okay. And what is the minor distributary? In this branch, which is this is the minor distributary. And what is the water course? Where is only water running on the surface, yani here. So this is the 5 type of relative canal. Now, classification based on canal. Classification based on canal alignment. So contour canal, watershed canal, ridge canal, and side slope canal. You can see in this map how water is flowing. Dear boy, if your dam height is 100 and command area is lower level, correct? Command area is lower level. So water can run frequently. Hey, no problem. Okay. And if both are equal, so will be problem to flow. And if it is high, then water will not flow and it will go by lift canal. So canal alignment, what is so general consideration for alignment? It should be aligned in such a way that maximum area is served with the last length and its cost including CD work is the minimum. Now, general consideration of alignment. First, you think, what is the alignment? Then we will read general consideration of alignment. Dear boy, suppose here is a village, here is a village, here is your dam going to pass this, here is dam or barrage also. Here is a village, here also a village, here a village, here and here also. When a line made for the canal, that is the center line, it comes like this. This is less, this is known as canal alignment. What is alignment? Which line is running the middle of canal, that is coming, that is the known as canal alignment. Now, a shorter length of canal has less loss of it due to friction and a smaller loss of water due to seepage and evaporation, so that additional area can be brought under cultivation. The alignment should be kept straight as far as possible. It will be result in minimum losses. The shorter length of canal had less loss of weight due to friction. So, my dear boy, what is the head? In the technical word, it is also canal alignment and head. Dear boy, when at the which level water is starting to move at the farmer's field. Suppose here is the river, here is your dam or barrage. I say mostly downstream of dam, we have constructed a barrage for the supply of water through canal. And now we are discussing about what is head. So, my dear boy, head means top. Suppose think that a plant is making, a elevation is making myself this sewage. And this is the water level. Here, water level is saying 240 meters. Here, bed level is 227. Here, sill level is 229. So, my dear boy, that is the question. Okay, how much water available in your dam? It means this is the 240 is the FSM, that is called head. Up your bed level is 227. It means, dear boy, and your sill level is 229. It means how much water you can send by canal in the farmer's field or generation of electricity. So you can send only 11 meter. You will ask, here is the length 30 meter. Why you are telling 11 meter? Yes, my dear boy. Because 2 meter you have left. Why? Due to ecological use on the river, which fisheries and other things who are living in the water. So that is how they will survive. So 2 meter we have sent that. And rest 11 meter we have to preparation to send the farmer's field. Up, suppose what is the canal and head. So if suppose your canal was here and one here. Canal is going like this. Canal top is 239. So you will flow, you can flow 10 meter height of the pressure in the canal. Clear? Yeah, any doubt? Now, a shorter length of canal has less loss of head due to friction. Up. Now you are thinking when canal is running, so how head are developing? What is the losses? So there is so many losses. First, we will discuss in this chapter what is the losses. First, seepage loss. The water entering in the earth and recharging the ground. Second, what is the second? Second is the evaporation loss. Evaporation. Water is evaporating. Okay, the stream of water is going to make the cloud. So this is the evaporation loss. Two laws you have seen. And now you will see another laws how we will govern. What is the another law? So my dear boy, suppose this is your river. This is the dam site and this is the command area. The water should become in the finally in the command area. Okay, but suppose dear boy, when you are making a canal from here to here, so many obstructions are available. So things see that this is a road, this is a railway line, this is a bridge. So this is a river, this is a river. So and if a road is crossing the canal, you will prepare a what you will prepare? A road bridge. Simple. And if you are facing a problem, the railway line is crossing, then you will prepare a railway line, a railway bridge. If the preparing of if the crossing of river, then what you will do? If river is crossing, then how you will cross your canal? Dear boy, you can keep few structure like you can give siphon or siphon equator or equator. It is depend upon condition. Which condition we are facing. We can give also super passage. We can give also level crossing, but it is not in our control. It is all depend upon situation. What is the level permitting on that? Suppose if river level is very down and canal level is very up, so you can provide there aqueduct. And if canal and river level are 2-3 meter distance and you have collect the data, these river are not floody river. Hardly 1-2 meter water come in this river in the flood time. So you can provide their siphon product. And if and if the level, the river and canal, the belt, the bed are same. then what you will do? You can do level crossing. And if railway line is crossing the lower level up to canal, matlab he is the lower bed of the canal, what you will do? You will provide the siphon. So many structures are available in the irrigation, and these laws, every structure gives you laws. Why? If you have constructed a bridge pier or any obstruction in the canals, it will be resist to velocity. Thereby, it will be resist to velocity. Okay. So this is the third technical naming loss. When you are planning the canal, after the survey, first you will made a head loss statement. How much obstructions are available in your way, and what structure you will provide. And addition to this, you will also provide a silt ejector, because if you will not provide the silt ejector, your canal will be fill up slowly by silt. So due to the seepage and evaporation, also you will be feel loss. Achha, what is the loss system? Actually, when you are constructing to any structure, so you are facing the loss of level. What, my dear boy? You will facing the loss of level. But if you are carrying the water in the channel, here you have loss of water due to evaporation and due to water recharging. Okay, so due to seepage and evaporation, so that additional area can be brought under cultivation. Now the alignment should be kept straight as far possible, and it will be result in minimum losses. If you are keeping the main alignment, what is the main alignment? Just I have explained that. What is the main alignment? Which line is passing the middle of the canal? That is not any real line. That is imaginary line. And that which are passing in the middle of canal, that is called canal alignment. So if you will keep straight, then no losses will be feel. But if you will be canal moving like this, suppose it is a canal this type, so many curvature will be made to you, and so many length of the canal will increase. due to curvature. Now you will think why? Because, my dear boy, suppose you are moving a canal like this. So you will see that here you will take a tangent point this, and here you will take tangent point this, and your tangent will be made your tangent will be made like this. So this length has bigger as per proposal. So he's saying the alignment should be kept straight as far as possible. It will be result in minimum loss. It should have minimum CD work. Now, general consideration for alignment, it should not passes through the village, town, forest, or costly land. Why? Because if it will be passed from the town, nobody will give to land with you. If it will be cost forest, it is the problem for the forest and wild animal. If it is the past costly land, then who will be give to you land? If it will be passed heavily compensation land, so heavy compensation you should pay for the purchase of that. So it should not passes through the village, town, forest of costly land. Otherwise, heavily compensation shall have to give in. It should be such that have cutting and filling embankment are avoided. Next thing, technical thing, have cutting and filling. Dear boy, what is cutting and filling? We'll see. Suppose you have made your canal like this. This is your canal's L section. This is the top of canal, and this is the ground of canal. Depth is suppose 5 meters. Okay. Now what is your ground position? If your ground position is like this, it means, my dear boy, canal is total going to the cutting. Why? You will cut this 5 meter plus this, 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 this. This is total in cutting. And when canal is going like this, and if your land position is like this, what you will do? So you will do fill off the bed. Your filling will be made like this. So this is called canal filling. Clear? And if third case, if your land position is like this, it is the best. It is tell partial cutting and partial filling. It means, my dear boy, this earth, this soil, you will cut and you will make here band and no more cost be involved in your expenditure. Correct? It should be such that heavy cutting and filling embankment are avoided. Just you have seen. Now, general consideration for alignment. It should throw passes the ridge so that both sides of canal be irrigated. Think that it is now it is the planning for how made the canal. So it should throw passes the ridge so the both side of made the canal. So what is ridge? We will see what is the ridge. So dear boys, if just if you have made a canal like this and like this, and your ground position is like this. So it means if this is the canal, the portion of this area is under the ground and this area over the ground. So you can supply the water 50% in the field and 50% go through forward for the other farmer. So, my dear boy, this is the called ridge. So it should throw past the ridge so that both sides of canal can be irrigated. And the alignment should be such that as far possible the balanced depth of cutting and filling is achieved. If you are going to plan, so after the canal survey, first you will take the survey for which land where you have made on the map. What called we call that alignment. We call that alignment. So when you are going to field on the survey of canal, so on that condition, you will try to keep that the balanced position of area taken for the preparation of balanced position of the canal. Correct? So now my next lecture, last alignment should not be made in rock and bricks are cracked strata. Or my dear boy, just I'm showing some picture, and after that, tomorrow we will carry forward to the other portion. So this is the bank. It will be, we will see tomorrow. This is very long. So this is the canal, and this is the canal. This is the uh, canal lining. What is the canal lining? When we are preparing the canal by only earth, by soil, that is the canal. And when for the safety of water due to recharging of the ground, that is canal. This is lining canal. This is the lined canal. This is the earthen canal. You can see this is the earthen canal. This is not lined. Okay. This is the lining canal. Lining by tiles. Okay. This is the making lining canal. This is the lining canal. We cast SC2 by cement concrete. So you will read tomorrow in my class. Some I think you will be. I will ask you when you have studied today MCQ. A multi-purpose reservoir is the one which and what setting? Tell Rob. Answer B. Planned and constructed to serve by this purpose. Correct. Now, arranging should preferably be fixed. Then answer in a open space. A rain gauge, here you will put the open space. Now, a repelling roll on is the align. What is answer? A pointing upstream. Now, a hydroelectric scheme operating under the head of 80-meter well. What is that? Is high head scheme. Correct. A land known as a waterlogged. What will you tell? This is the capillary irrigation reached by root zone of the plant. So now a hydrographic, a graphical representation of what you will tell? Answer rainfall intensity at time. Now, what is the 70% of index of the wetness mean? Thereby, it means rain deficiency of 30%. A current meter is used to measure the velocity of flow of water. Yeah, depth of flow of water. What is correct? Answer is 1. Velocity of flow of water. Now, a deep well then is always deeper than the shallow well. No. Has more discharge than a shallow well. So next question, a divided wall is provided. What provided? Answer, at the right angle to the axis of wear. So this is the reference of book and this is the reference of book. Thank you for joining my class. Uh, I will welcome to you, all of you, at the tomorrow, the part of the canal next. Okay. Thank you for all for joining.